All right. So today we are reviewing for your quiz. That is tomorrow. Your quiz tomorrow for the students at home. You are required, oh, we're all going to be home. Never mind. We're all home. So it is required to have 2 devices, one for you to take your test on, and then the other one so that your camera can be on and we can see you. And so you'll join the Zoom on the one that you want your camera on for your Zoom. Any questions on that?
So it's the same way the last test was run.
It's just a PDF, right? And we're just pulling it into Notability or whatever app you're using. So it's just like you can paper and pencil, you show all your work. All right, so to take out your homework from last night, we are going to look at a problem on there. And then for tonight, you're going to have another review sheet, but you should have, we're going to give you about 15 minutes to work on that in class so that you can get any questions answered and we can go through maybe another application problem on there. All right. So the only questions on the homework form were from the second page of the applications. So let's look at number 13 first. So it says the dimensions of the old stage at a concert hall were 30 feet wide and 15 feet deep. The new stage has a total area of 1,000 square feet. The dimensions of the new stage were created by adding the same distance x to the width and the depth of the old stage dimensions. What is the value of x? So we know the original stage is this 13 by 15. So I'm going to go ahead and draw my stage at 30. I said 13. 30 by 15. So now we are adding the same distance x to the width and the depth of the old stage. So just like how we did the problems yesterday, what problem was that? Wasn't the pool, wasn't the quilt.
That was the garden problem.
The garden problem. We're adding the same distance to both sides. So just thinking about that, we're adding x, 30, and we're adding x to the length and the height of this stage width. And I'm just going to connect them. Let's make this look a little prettier. So then what is the length of this whole side, Riley?
13.
Awesome. And what about the length?
30.
Perfect. So how should I set this up? Okay.
1,000 feet equals parentheses 30 plus x parentheses and then 15 plus x.
Awesome. Because the total area of the new stage is that 1,000 square feet. Good. And then what step should we take from here? Riley, go ahead.
Boil it.
Foil it. Yeah, we foiled this right side. And then what should we do with that 1,000 once we foil? Yeah, we want it to be, get it to equal 0. When you do that, we know how to foil. We would end up getting x equals 10 and x equals negative 55. So I'm not going to go through the foiling process here. We know how to do that. You would then get 10 and negative 55. If you didn't get that, you probably just had a mistake foiling. Faith, which one of these is not the answer? Negative 55. Good. So then we know that we are adding 10 feet to each side. And that's how you would write your answer. They're asking what the value of x is. You could just say x equals 10. They're not even asking for a label. So this is the new part of this problem that we've been doing. We've been foiling. Questions on this one? Cool. I want to make sure you go through the setup of these with you. You are making a picture frame of uniform width for a picture that is to be displayed at the local museum. The picture is 3.25 feet tall and 3 feet wide. The museum has allocated 15 square feet of wall space to display the picture. What should the width of the frame be in order to use all of the allocated space? So we have this picture. Which is 3.25 feet tall, 3 feet wide. And when they're saying uniform width, what is that talking about? The frame is of uniform width. Leah, what are they talking about there? Good. So this is like that full deck problem. So my frame here, I'm making it big. I'll go ahead and make that X. That's an awful frame, but I think you understand the picture here. So we have 15 square feet to use. Jordan, what's the length of this whole side?
3 plus 2x.
Yeah, because we have to think of both sides, x on both sides. So then what about the height?
3.25.
Beautiful. How would I set up this problem?
15 equals 3x plus, or 3 plus 2x, and 3.25, or times 3.25.
Awesome. Questions on how we set it up there, the picture, and my awful crooked frame. All right, so now I'm gonna go through and foil here. There was questions on when we have decimals. So when we are foiling, what are we gonna get? What's that, 3 times 3.25? Malachi?
9.75.
3 times 2x. Oops, not x, my bad. Three times, go ahead.
Oh,
Yeah.
6x.
Awesome. What about inner?
6.5x.
Awesome. And last.
Minus 4. Wait. 2x squared.
Close. We have 2 times 2.
Oh, 4x squared.
Yeah,
My brain's not working.
it's all good. 4x squared. When we combine like terms here, I'm going to rewrite it so that my greatest power is first. 6 plus 6.25x will give us 12.25x. We still have that plus 9.75 equals 15. Faith, what should we do to that 15?
Subtract it.
Good. What would that give us when we bring it over?
Negative 5.25.
Awesome. So now this is equaling 0. Now, what is the decimal on two of those numbers there? Riley? 0.25. So if I wanted to, so I know that if I wanted to get rid of those decimals, what could I take out? Think.
0.25.
Yeah, we could take out 0.25. We don't want to deal with those decimals. Because we know that 0.25 goes into all of our numbers. When we take out 4 out of 0.25, we're going to get 16. When you take it out of 12.25, you're going to get 50x. And out of 5.25, you're going to get 21. And boom, your decimals are gone.
Anybody have questions about how she got those numbers? When you take out a value, how do you get those numbers?
Go ahead.
The second actually is 6.5.
6.5.
Yeah.
Second F here,
No, it should be like comparable for.
up here.
Yeah.
6x. 6, yep, 6.5. Thank you. So then that messes up right there. Thank you. And now that should be 50. Any other questions? Yeah, how we got those numbers out?
So you know when you GCF in front, you're dividing by that GCF. That's how you're getting the numbers inside.
All right. So now that we have the 16x squared plus 50x minus 21, what should we do to factor that? Jordan?
Wouldn't you multiply 16 and
Yep. Then AC. And what does 16 times negative 21 give us?
negative 336.
And we know that we need factors of 336 to add to 50. Is anyone able to get these factors? Faith?
56 and negative 6.
Yeah. Good. So I'm going to rewrite this as 16x squared. And then we did grouping. So what do you take out of the first two terms? Malachi, what do you take out of the first two terms? What's common there? 8. Is that it? Kind of drew over it. This 56 also has an x. Yeah, x. So when we take that out, we will get 2x plus 7. And what about with the second two numbers? Jordan, what's common to both 6x and 21? Negative 6x and negative 21. Negative 3. Which will give us 2x plus 7. Bring them back together for grouping. Combine those GCFs we took out. 2x plus 7. And here, this doesn't make a difference since it's just a number, but it's important to remember to bring that down with it. And now this is equaling 0. Using zero product property, we can set each of these factors equals to 0. When we do that, we'll add that 3 over. X equals 3/8. Subtract the 7 over, and we get x equals -7/2. Leah, which one of these is not the answer?
-7.
Yeah. So we know x is 3/8. And they are asking us what the width of the frame should be. And that is what we said x is, the width of the frame. So it's 3/8 feet. Width of frame. Questions on this one? So when I see decimals, I like to get rid of them, or fractions. Take something out to get rid of those decimals or fractions. Questions? All right. So then I am going to set up the next problem with you. This one was talking about an area. So we have the area of a triangle, which is 27 feet. The base is 4x plus 1, and the height is 3x. Draw my triangle. The base is 4x plus 1. The height is 3x. This requires you to remember what the formula for the area of a triangle is. What is that? Faith?
Base.
Perfect. So what is our given area of the triangle? What did they say?
27.
Good, 27. 1/2. Our base is that 4x plus 1. And then height is 3x. Good. Then you'd multiply through on this side. Questions on the setup?
That's an easy way you can get rid of that 1/2 fraction. Besides distributing it through so that you don't have to worry about having fractions on the right side.
Multiply by 2 on both sides.
Yeah, and that's an easy way in this case to get rid of that 1/2 fraction in the front. Instead of distributing it through, think of ways to get rid of it as well. You don't always have to distribute a fraction through a problem. I think that makes this one easier if you get rid of the fraction by multiplying it with its reciprocal on both sides. So then you have 54 equals, and whatever the right side distributes when you distribute the 3x.
And Jordan, what does that equal when we multiply the 3x through?
12x squared plus 3x.
Perfect. And then how do we get this x equals?
Can you find the GCF?
We can. What should we do first before we do that?
Oh yeah, subtract this.
Yeah. Good. And Jordan said we'd take a GCF out. What did you say the GCF was?
3.
Perfect. Which leaves you with 4x squared plus x. And what do you get for the last term?
Maybe 8.
Yeah. Because I forgot my negative. In front of the 54. Awesome. And what do we do from here? Malachi? Oh, that does not look right. Yeah, how would we factor? What method? Yeah, good. AC method. So then you'd go through and multiply your 4 and 18. When you go through all that, your final answer should have been 2. If not, make sure you got to this step. Questions? Got 2 is that final answer? Good. All right.
Part.
Yes.
So this is kind of going back to the last two problems, but why for number 14 did you have 2x and then number 13 you only had 1x in the parentheses?
For 13?
Yeah.
Oh, okay. I see what you mean. So for the do you understand how we made this diagram here?
Yeah, so whenever I drew my diagram, I had x's coming from like every corner, like how we did in number 14.
Okay. So that is if we had uniform width. That's if we were adding the same length all around this stage. But here we're just adding the same distance, it says, to the width and to the depth. So we're going to take the width, add x, and we're going to take the depth and add x. When we are adding the same distance to every side, like we did in 14, that's when you'll see that term uniform width. Oh, yeah, I already underlined the uniform width here. That means it is uniform to all corners. It's the same to all sides.
Oh, okay. Thank you.
You're welcome. Any other questions? All right. So now head over to Google Classroom. We are going to work on another review to review for your quiz tomorrow. And the rest of the time, we are going to work on it. So this is your time to ask questions. If you know you struggle in a certain area, now's the time to work on those questions when you're in class so that we can get everything figured out. We can look at, there's 3 application problems, or really just 2. 2 application problems on this review worksheet. The whole first page is factoring. I know there's 4 application problems, so they're simpler than what we've been doing. So I'll give you a second to pull that review worksheet up and we're going to look at an application problem together. We're going to look at number 20. All right. So it says a rectangular garden measures 10 by 15. I'm going to draw my garden. We have 10 feet by 15 feet. We are adding x feet to the width and x feet to the length. So Ava R, how should I draw this diagram? I'm adding the same length to both the width and the length.
Should there just be 2, like there should be an x coming from there and then an x coming from the corner? Yeah.
Yeah. Good. So then what is the length of this whole side? I'll draw my numbers in a weird way. Go ahead, Ava R. What's the length of this whole bottom here?
Would it be 15 plus x?
Yep. What about the length?
10 plus x.
Awesome. Questions on the diagram? So they're saying our area is doubled. What's our original area of the garden, Riley?
150.
Yeah, 150. Our original area is that 10 times 15, which Riley said is 150 feet. So then if we want to double the area, what should our new area be? Malachi? Yeah, 300. We want to double it, multiply it by 2. So it'd be 300 feet. When we're setting up this diagram or the equation, what should that look like, Leah?
300 equals 15 plus x in parentheses, and then another parentheses is 10.
Awesome. And I think we are good from here on out. Setting up the diagram and the equation is the most important part of the problem. I'll give you a hint here. They're asking you to find the new dimensions of the garden. So when you find that x, you're going to have to go back and find the new dimensions of the garden. Okay, so I will give you this time to work. If you know you struggle with application problems, I recommend you work on those now so that you can ask questions when you're stuck. If anyone from home has a question, you can just unmute yourself. I'm just going to be walking around the room.
Yeah. Well, we're doing right now, but it's only like 1 day a week. Not as much. Yeah. Is that inside?